9:30. Let's talk science now. New science, of course, with Janine Young over in Melbourne, Australia. Good morning, Janine.
Good morning to you.
And today we're going to be talking about something that both Australia and New Zealand have a significant interest in, and also South Africa, unfortunately, vying for the right to host the Square Kilometre Array. Now, what is this?
It's not anything that's not something we don't want. As you say, there's a joint bid that's been put in for both New Zealand and Australia to host this, what is essentially a giant telescope. Now, they're not building one that is a kilometre across, but that is what the equivalent radius of what this would be. What it is a giant set of a lot, and I mean a lot, of different telescopes that can all combine their signals together to effectively be the biggest telescope ever built. It'll be about 3,000 dishes across a 5,000 kilometre radius. And so I'll have 2,000 in that initial 5 kilometre radius, and then they'll have 3,000 kilometre spiral arms that will go out from that central point. They'll also have smaller antennas that will be able to pick up lower frequency signals. And by combining all that data, they'll be able to look further back into time. And as you do look back, you can see different things. And they'll be able to see things that have never been possible before. So you can see why that there is a lot of interest in being able to build this thing. South Africa is naturally saying that it has the best site, and Australia is saying, no, actually, we reckon we do. Decision is due on April 4th, and there has been some discussion in the media recently, certainly here in Australia, about the fact that our bid was dead in the water.
Yeah.
The fact that the European delegates on the committee think that it's actually a fantastic development opportunity for Africa, so therefore it should go there. However, the last few days there have been reports saying, no, everything is fine, it's on track, everything is okay, but it's a tense time because this has been at least 4 years in the deciding, the lobbying, the planning. This is no small undertaking.
Do we know anything about some of the pros and cons with putting it in Australia versus South Africa?
Well, South Africa actually has, it's an area called Karoo, and it has about 40% of the landmass of South Africa and about 2% of its population. Now that means that it's actually more populated than Australia, because the Shire of Murchison, which is up near Geraldton, up in the northern part of Western Australia, has a total of 110 people across 50,000 square kilometres.
Yeah.
That's an extraordinarily small population. However, the South Africans are saying that they have the advantage because it's more populated. They've had to develop very specific technologies to make sure that radio frequency interference, and that's what this is all about, it needs to be away from population simply to try and reduce the interference, because what they're looking for is so tiny that is very easily interfered with. They've developed very definite specific technologies to be able to keep these radio frequencies away. So telephone companies have been forced to develop technologies that mean that they direct their signals towards towns but away from this sort of site. Australia is saying, look, we've got no one out there. That's our big advantage. As I said, there's some talk of this being a development opportunity for Africa.
Yeah.
There's pros and cons for both sides, and I would suggest that they're both incredibly strong contenders because they wouldn't have made it this far if they weren't.
That's very true. And apparently, if Australia gets it, there's some talk of one of the arrays going in New Zealand. Any idea on that?
There is, yes. This is not just an Australian thing. The whole idea is that by having lots of different telescopes that are different distances apart, you're able to get a wider range across the sky and able to pick differences more. So that's why, by including one in New Zealand, and I'll confess that I don't actually know specifically where.
No,
I apologise.
Probably the deep south, I'd say.
Well,
Otago
I think actually you're right.
Yeah,
there's not a lot down that way when you think about it. And I've been there twice, so I can say that with some, put my hand on my heart and say it with some validity.
Yeah.
There's not a lot there at all. By doing that, it means you get a greater resolution. And that's why you have this massive radius that they're talking about. For example, the sorts of things that they're talking about being able to do is picking up a number, and I mean at least 10,000 more pulsars than we can currently see at the moment. Part of the problem with telescopes at the moment is that they can only see very narrow bands that go a long way back in time, or very wide bands that don't go very deep. So that's just the nature of telescopes at the moment. But what they want to do is to increase that so that they can actually find up to 15,000 pulsars. We know about 2 at the moment. They're a source of low-frequency radio waves. They're left over from stellar explosions.
Yeah.
And they're a neutron star. They're rapidly rotating. And you kind of think, well, that's nice. Why do we need to know about them? Well, we should be able to keep an eye on them. You can actually see gravitational waves going past them, because as a wave passes, it stretches and compresses gravity and time. It changes the time-space fabric. So being able to see how that changes actually means that it's a test of Einstein's theory of general relativity. Now, I'm not going any deeper than that. It's too early in the morning for absolutely everybody to start talking about relativity, especially me. But being able to do this kind of thing, being able to go back into time, looking at how hydrogen has changed and moved over time, looking at the ionized stuff that came out of possibly the earliest explosions of the earliest stars, and it's never been proven, being able to work out what's going on there, being able to look back into the earliest reaches of space and the universe is pretty incredible stuff, you know. But having the resolution to do it means that you do need a number of different telescopes across a number of different sites. Africa wants to place it not only in South Africa but across 8 other countries. So again, it all comes down to having them spread out so you can get that resolution to be able to see that far back in time.
Fascinating. Well, we will follow that with interest, and hopefully it comes down this part of the world. Staying with gravity, though, and an interesting story about how a gnome is helping out with our understanding of gravity.
Forget the genome. This is all about the gnome. Literally, there is a gnome travelling the world at the moment with a set of scales, and it's being weighed at different points on the Earth because, and most of us wouldn't realise or care, at different points on the Earth, gravity is different. That's because the Earth bulges.
Yeah.
At the poles, it's being pulled out a little bit more. So that means, at the equator. So at the poles, it means that you're ever so slightly closer to the centre of the Earth, which means that gravity is different.
Huh.
So you weigh just a little bit more because it's pulling on you. There's other effects that need to be taken into account as well. So this is not necessarily scientifically accurate to, and if you measure it in grams, that's wrong because you've got mass versus weight. It gets kind of complicated. But the principle of the thing is saying, look, people, gravity is different in different places, and that could have implications for very specific, minute measurements for, compounds, for example, that are coming from one part of the world and being delivered to another. You think you're getting a certain amount, and you may, in fact, be getting more or less. Gravity is different and it does change. There you go.
Why a gnome, though, with these scales? Is this just a gimmick, or...?
Yeah, I'd say that bit is a gimmick. There's a company that manufactures scales, and so they are the ones that are trying to raise awareness of this. And yes, it is a gimmick, but I reckon it's pretty cool. We've got photos on our website of the gnome at the South Pole and in Sydney, and he's been to Lima in Japan and Mumbai and San Francisco. He's been all over the place, and so he's going to go to the Large Hadron Collider in CERN and in Switzerland. So
because
it's a bit of a gimmick.
Don't they keep the actual measurements and weights somewhere in France? For what is a kilogram or
yes.
Yeah.
The international standard for weight.
Yeah.
Is definitely, it's a very specific thing, and there have been arguments recently about the fact that you need to have these standards and the fact that they vary, and you kind of think, well, is it really important? Actually, yes, it is.
Yeah.
It's extraordinarily important to have these standards correct. Even time isn't measured by a ticking of a clock; it's actually by an atomic clock, which is by far more accurate than anything you and I will ever need.
Yeah.
But it does impact on our lives in various ways because computing relies on accurate time and the like. So. Yes, people, be interested in your standard weights and measures. It's important.
Indeed. Janine Young is over at New Scientist, and as she was saying, you can check out those images, newscientist.com, and also New Scientist magazine. Thanks very much, Janine.
See you next week.
Time now here on Kiwi, 29 minutes past 8. Got a track from Fabulous Arabia.